Oh, perfect. Of course, a live demo. Maybe it doesn't, it's not called, oh, it's called Unifex demo, okay. Now it seems to work, and we can do Unifex cnode call, function and arguments, and it works. Even though we have to use a separate API on the Elixir side, we can use the very same C code and interact with it in via different interfaces, which personally to me seems like super cool feature. Also, as I said before, if a code like an if crashes, it crashes the whole beam. So we can try to do that. Let's recompile this. So we can see that the C node exited, but the beam still is alive. Though when we use NIF now, Unifex demo it was called, the whole beam crashes with segmentation fault. So we basically can choose between the drawbacks and the pros of each solution very easily just with Bandex AXS file. Well, okay, let me continue. Yeah. There is another limitation of C nodes that they require distribution, but also they are pretty they have poor support for distribution because they don't handle, for example, IPv6. So especially if you already have a distribution in your Erlang system, that may be a bit tough to integrate. So this issue, there is a conclusion how to do that, and yeah, no one did it. The answer to this problem is to use ports. Ports are separate operating system processes, but they don't pretend to be Erlang nodes. You just communicate with them over a standard I/O. There is a port module to do so, and for example, system.cmd command uses ports under the hood. So ports, they have their limitations as well, of course. The overhead is pretty similar to C nodes. When you create your own code and you interact with it via port, it's quite not problematic, I'd say. But there are problems when you just have a third-party program and you want to interact with that. Also, there is no built-in support for Erlang terms, so you just write to STD or STD input and read from STD output binary stuff. So third-party ports have these two problems in particular. When Beam closes a port, it closes the STD input and output, but it doesn't kill the process actually. So zombie processes may happen. And also there is no back pressure, so the port can flood the Erlang process with data. There are several libraries that try to mitigate that. I only used Porkline out of these, but don't use it. It's recommended in many places because it used to be popular, but it's not maintained and has known bugs. These libraries seem pretty cool as far as I've seen them, and they have different approaches and different trade-offs. So if that's your case, definitely check them out. Also, I said that you have to send the bytes to ports, but you can actually send encoded Erlang terms, and that can be done with the use of external term format, which is specified in Erlang documentation, and there are Erlang term to binary and binary to term functions, and it's used by Erlang distribution internally. So when you use C, you can also decode that Erlang term format packets with Erlang interface, the very same library that is used to interact with C nodes. Also, there is a cool library called Erlpack that is done by Discord and that allows to decoding and encoding this external term format in JavaScript, Python, and Go. There are also many other libraries, and this external term format is pretty simple and doesn't change. So even if a library seems not maintained, maybe it's worth to try it, and it may be like very useful anyways. You may heard also about things like port drivers. There were actually predecessors of NIFs, and now they aren't explicitly deprecated, but that was my impression. So that they are not really like encouraged. So I asked on the Erlang forum, and the guy from Erlang core team answered that indeed they are going to remove that functionality eventually. Also, for another option to look at interoperability. When you are calling like some code from Erlang, you can use like this native ecosystem to run that code, to compile that code, but you also can write an interpreter in Erlang itself. And that's what one guy did, and it's called Luarl, and it's used to execute Lua scripts in Erlang. It can be really useful to execute some untrusted code that should be sandboxed, and to allow users very flexible scripting without like the risks that come with executing untrusted code in Erlang or Elixir. So that's like another point of view at interoperability. And this is basically all I prepared. So all this stuff I showed is in the repo on my GitHub. And there is also a cool talk by Andrew Bennett on how to deal with dirty NIFs. It's pretty old because it's already 5 years old, but I think it's still quite up to date and really interesting. Also, other stuff I mentioned, and I'm not sure if we have time for questions. Do we have? We have. So, any questions? Okay, so time for questions is not needed anyways. Thanks a lot.
Okay, thank you very much, Mateusz. I've seen that some new people have arrived to the office. So firstly, I would like to say hello to all of this, as well as I would like to say hello to all the people who are now hidden behind the screen, because we have finally faced the technical issue with our stream. So hello. And just a quick reminder, especially for those who are like new here at the office, when it comes to the toilet, it's located behind you next to the elevators. And we encourage you to go to the kitchen, take some drink, or grab a bottle of a beer which is in the refrigerator. And in a moment, we'll start the other talk.
Działa? Okej. Okay.
Kuba, czy ty... Okay. Yeah, so maybe we'll like take a moment and wait for the people to come back.
Może Miro, co poszło? Jeszcze nie. Sorry.
Once again, I need to ask for some patience since we are having some another problems. Okay, so we are probably back in the game. So let me introduce to you our second presenter today, Wojtek Mach from Dashbit company, who will be talking about an HTTP client he wrote himself. So, Wojtek, take your time. You can start.
All right. So again, I'm Wojtek. I'm going to be talking about Rec, which is a client that I wrote some time ago. It says it's batteries included. So what I mean by that, batteries included, you kind of take it out of the box and you're good to go. So sometimes the Python language is described as such. The standard library is pretty comprehensive. It contains stuff that most developers would need most of the time. You don't necessarily need to reach for other tools. You don't need to necessarily write a lot of code. So that's what I wanted to do here with Rec as well, to have this nice out-of-the-box experience. You don't need to reach out for other things to do common tasks. So let's take a look at how it looks like to work with recs. So maybe we have an IX session and we can mix install rec and call rec.get. So here I'm using the GitHub JSON API for the rec repository itself. And this is what we would get back. So here we got the HTTP status 200 OK. We got a bunch of headers. It's more than these two. I chose these two for a very particular reason. And we got the HTTP body. And so the headers that I chose to show, so the first one is content encoding, which means that over the wire, the server sent the response compressed using this algorithm, gzip. And when rec sees this header, it will automatically decompress it. And so, as a matter of fact, the servers don't really compress body by default. They would only do so when asked to, specifically when the client sets the accept encoding header. And this is what rec does. So by default, it will ask the server to compress the body, so we save on bytes. And this is kind of the, so to speak, rec approach. We try to use HTTP headers and do some, basically have opinionated defaults of how the client should work. Based on these headers, we also set some headers ourselves. So the other header is content type. So here it's application JSON. And similarly, when rec sees this header, it will look at the value and try to automatically decode. So it did decode the JSON into Elixir map. So again, this call, what I like to often do is to access the body field directly. And then if I work with JSON, it's going to be automatically decoded. So I would reach for the key. So yeah, this is the description of the project. Instead of making the request directly, we can also first build up the request, maybe save it somewhere, and only later on actually execute it. So again, we have the same result. And the idea is that you would use these two different approaches in different circumstances. So maybe the first one, you're just playing with something or exploring API, having like a one-off line. This second approach is especially useful when you are maybe building up the request first with some basic options like the URL or headers, authentication, and then maybe later on you want to do a bunch of requests using the shared setup. So yeah, what are the batteries included? What are the features? So the first one, I would consider it as a feature. My goal is to have this nice high-level API. You just have a bunch of functions. You just call them, and it's basically it. Another feature is we have request body compression and automatic decompression. So we've seen the automatic decompression in action already. Here I mentioned that these features are implemented as using these steps. So we're going to talk about steps a bunch. So rec by default supports the gzip and deflate compression algorithms. And if you install some extra packages out of the box, it will support Brotli and ZSTD as well. We support request body encoding and automatic decoding. So again, we've seen the decoding in action. We automatically decode the JSON. We can easily encode parameters as query strings. We have support for authentication. We even have the .NET RC file, which is pretty useful for scripts and such. We can easily make range requests, follow redirects, retry when we face errors, raise on an HTTP error. So by default, we would get a response back, but maybe we want to raise if you actually got a HTTP error. We have very basic support for HTTP caching. That's something that I want to improve. We can set base URL. We can run against plugs, and we have pluggable adapters. So we're going to talk about these two later on. But rec by default uses the excellent Finch HTTP client. Finch in turn uses the excellent Mint HTTP client. So it's layers over layers over layers. So I mentioned that we have steps. So one of the goals that I had for Rec was to have good documentation, and so we have this. So basically, all of the features are implemented as steps, and steps are just functions. And one of the nice kind of consequence of that is I can then document every step, every function as a separate thing. So here we have the follow redirects step. It accepts a bunch of options, like we can disable the automatic redirects, we can set max redirects. Here we also have code samples for this feature. And if you look at the sidebar, you will see other steps, and we have 3 kinds, which we are gonna talk about next. So if we have these batteries included, so to like stretch the analogy a little bit, let's talk about replaceable batteries. So we ship with a bunch of features, and let's talk about how we can rearrange these features or write new ones, how to basically write new steps, how to extend Rec. So Rec basically has 3 pieces: the Rec module, the high-level API that we've seen, the Rec request, which is what I like to call a low-level API. So this is the API that you would use to write your own steps or to add these custom steps to your requests. And then you have the Rec steps module, which is just the collection of all of the built-in ones. So let's talk about the request struct. If we call this Rec new that we've seen, so here just for the presentation, I'm passing 2 options, the URL and just the follow redirects to false. We would get back the struct. So we have the basic HTTP stuff, the method, URL, headers, and body. We would keep track of the options that were given. So here we store the follow redirects, and this is because, so this is so that the steps can look at the options and do some logic based on these. We actually keep track of all of the available options, and we're going to talk about that later on. We have halted, so this is kind of like the plug, con, halt, and adapter, which we are going to cover later. And now we actually keep track of all of the steps as well on this request. So by default, Rec will put all of these built-in ones, but you can rearrange them as you wish. So these are the request steps. These are the steps that happen before making the network call. So this would be setting headers, setting body, setting a URL, and so on. We have response steps. So after we got a response back from the server, we would run these. And then we have error steps. So if instead of a response we got an error, so maybe there was a timeout, maybe the server is not even there, we'd get an error, and then, yeah. So we also have private field, so just to store some arbitrary state between steps when you implement them. So let's kind of describe like basically how Rec works on a very high level. So when we make this call, it is as if we would be building up the struct, and then we would be running steps on it. So here we set the default user agent, and so this is a step. This is a request step, and these take a request struct and they return it. So we would be kind of like piping them. So we would set some headers, maybe encode the body, compress it, and so on and so forth. And at the end of the request steps, we would call a kind of special step, which is the adapter step, so making the actual call. Again, we use Finch by default, and this step is just a little bit different. Instead of returning the request, it would return either of these 2 things. So that would be either the request response tuple or the request exception tuple. So in the first case, we would kind of take this tuple, and now we would be passing it through response steps. So again, maybe if there was an error, we would try to retry. If there was a redirect, we would try to follow it, decompress body, decode body, and so on and so forth. And in case of error, we would again take the tuple and try to maybe retry the error. So like on a very high level, this is roughly how it works. It's just passing data around. But obviously, it's not quite as simple to support use cases like following redirects and so on. So think about it that as if after calling each step, there is like a breakpoint, and rec basically kind of takes over and does some control flow. So again, we have 3 different kinds. Let's build a very simple step. So here we are just making a request to this website. Let's build a step that just adds some debugging statements. So a step, again, just a function, takes a request, returns a request. Let's just inspect the URL. And this is how we would use this step. We would use this rec request append request steps function to add it to our pipeline. So the append word is kind of important here. Again, steps need to run in a particular order. It only makes sense to decode the body after decompressing it. So we have appending to add them at the end. We also have functions to prepend them. So again, let's see the contract. So request steps, take a request, return it, response steps, take the tuple and return it, error steps. So with such a contract, we can actually go pretty far, but it is not quite enough to implement all of the use cases that I wanted. So a request step, instead of just a request, can also return this tuple. And here's an example. Maybe we have a step that tries to return a cached response. So we take the request, we look it up in the cache. If it was cached, we just return the request response tuple. And now what's going to happen is rec will no longer pass the request through the request steps because, again, like we don't want to actually make the request. So it will take this tuple and pass it through response steps. And similarly, a request step can return the request exception tuple. And so here's an example. Maybe we have a circuit breaker step. If the breaker is open, we don't want to make the request. We can just return the tuple with the exception. And we are not going to call any other request steps. We are going to call error steps. And similarly, response can kind of go into the error steps. An error can go into response steps, so we can have these flows. All right, let's try to do a demo. So there were a bunch of technical difficulties. Let's do live coding and let's hit the network. What could go wrong? So here I have a live book with just some basic setup, so you don't have to see me typing it. This is again the hello world. So it works. So let's do some minor changes. Let's change this HTTPS to HTTP, and GitHub is going to automatically redirect to use the HTTPS as one should, and rec picks it up. It says it is following the redirect, and so we have the same result because rec automatically redirected. Okay, so let's now do something else. Let's take this URL, and we're going to create the rec struct ourselves. So yeah, it's hitting the network part. Okay, yeah, we are good. So now what we can do is we can change this to base URL. So imagine you maybe have integrated with some API. You want to keep the base URL the same, but at each call site you want to just use the particular part. So again, we have the same result, but now what we can do is maybe check out Finch. So Finch, Elixir HTTP client focused on performance, and I really cannot praise Finch enough. Basically, because it is focused on performance, I don't have to. I get all of the benefits for free. Let's check out something else. Let's hit this URL, like a bad URL. We got a nil, and the reason is we got the response, but the response didn't contain that key. So when we would call, when we would write code like this, it kind of expects that we got the successful response. So what we can do with rec is say HTTP errors raise. And now, if rec sees errors in the 400s or 500s, it's going to automatically raise. So this is kind of useful for, again, maybe you have one-off scripts, you don't want to do error handling, but you still want to have like a reasonable error. So there is quite a few options, and sometimes maybe you can mistype the options. So we have some affordances here as well. If we mistype the option, we're going to get this error which says, so unknown option this, did you mean the actual thing? And we can do this exactly because we keep track of all of the options that are on the request. So this is the list. And again, if you write custom steps, maybe they accept options. So there is an API to register these options with rec so that it sees them. Okay, so one of the features that I wanted to, like one of the stories with rec I wanted to have is around testing. So maybe you are familiar with Bypass. It's a very nice library which allows you to basically use the plug contract, so it's the con, and kind of basically set like a count response, a mock created like a mock response. So we support this with rec as well. Basically, we can do this. So let's save this off as a fake, and let's add this plug option here. And now what is going to happen is, let's remove everything. Now instead of hitting the network, rec is just going to hit the plug. So this is pretty useful for tests. Another way to test. So again, maybe you are integrating with third-party API. You want to have a count response in tests. What we can actually use is the adapters. So I mentioned we have the custom adapter, pluggable adapters. Finch is the default one, but you can write your own. So let's write our own. Instead of con, we'll take request. And what we're going to do is return request response tuple. And for the response, let's just create maybe something like this. Yeah. And typo here. Yeah, Bodji. Nice. All right, I think we are good. So we have this adapter, and if you remember the slides about the contract, adapter is just a step. It's just a request step, and the only kind of special thing about it is that rec will make sure it is the very last step. So if you, again, the testing story, if you happen to be working with JSON APIs, maybe you want to return like a mock JSON. So there is a little JSON function here. And we would get the appropriate header, content type, application JSON, we would get the body. So the body is already decoded because rec does so by default, so we can set the raw true option to not do any decoding. So in fact, we got over the wire the JSON body. Okay, so these are like the basics. These are basically the built-in steps. And I quickly wanted to show, so basically when you write new custom steps, to make them even easier to use by others, you can package them up as plugins. And there isn't really like a plugin abstraction. A contract is just a convention. But let's actually see that. So we're going to remove all of this. And let's hit the Elixir Lang website. Okay, so we got the HTML. And now let's add a rec easy HTML plugin. So this is just a small plugin that I wrote. And what it does is, okay, let's execute this. We attach the plugin, and again, this is purely by convention. Attaching the attach function just adds appropriate steps, and now what we are gonna get is this easy HTML struct. It basically parsed all of the HTML, and now it happens to have a custom inspect implementation, so it's pretty printed, and it also implements the access behavior, so we can do CSS queries. There is an H5 element in there, so we can check it out. We have the Elixir tagline. Let's quickly check out another plugin. So there is a rec S3. Let's execute it. Let's attach it. And what we can now do. So yeah, notice that attaching the plugin doesn't really do any work. It should basically plugins should trigger on a particular thing, like maybe particular URL or particular set of options. And the S3 one is exactly that. So there is this OSCI datasets bucket on S3, which contains some training data for machine learning. And with this plugin, we can just use the S3 custom scheme. And what we're gonna get is actually the list of objects in this bucket. So this is kind of this. This is what the plugin does. This is like a little convenience to check out the stuff on S3. And we can of course hit get the actual object. Yeah. So there are other plugins. There is a BigQuery integration and Athena by my colleague Ale. I wrote some stuff for Hex as well. We probably don't have time to show the GitHub one, but yeah. So going back to the presentation. So again, stretching the library, what are the missing batteries? I want to add cookie support. I want to add request streaming, which is pretty trivial, but I want to do it only when I know how to do response streaming, which is not. So basically the problem is that I have this abstraction in these steps, and it is not yet clear to me how to basically fit chunked responses into them. But yeah, before shipping 1.0, I want to solve all of these problems. And I was planning to do a comparison with other HTTP clients, but I don't think I could I could do them justice in a short talk like this. So if you want to talk about maybe some comparisons, I'm happy to do this afterwards. And these are the URLs. And thanks for your time.
Okay. Well, thank you very much, Wojtek. Are there any questions to Wojtek? Okay, so just give me a second. I will pass the microphone to you.
Thank you. This is just a quick one on your philosophy of handling like inconsistencies. So imagine, I really wanted to interrupt you when you were doing the JSON thing with the plug. Yeah. So what happens if the server advertises that the response is going out as application JSON, but it sends, you know, HTML? Oh, we had a problem with the server. What ends up in the response struct?
We are gonna crash.
Okay, sounds good.
We just use the JSON decode bang. Yeah.
Thanks.
Okay, so are there any other questions? I cannot see.
Cool.
So
yeah, happy to answer any questions later on. Thanks again.
Thank you very much once again. Okay, so meanwhile we are preparing for the next presentation. I would like to announce that in case any of you has a desire to actually have such a talk here during the Elixir Community meetup, feel free to contact us on our meetup group or via the Twitter. Okay, so let me introduce to you our today's last speaker, Bartek Błaszków, who is also my colleague at a membrane team here at Software Mention, and he will be talking about a web server in Elixir. So Bartek, stage is yours.
Thanks. Hello, everyone. Today I would like to speak to you about a little tool that I've created as a byproduct of working here. It's a very simple HTTP server, and for those of you, and it's a replacement for the Python server. Like as Wojtek said, Python is considered to be battery included, and one of the things it includes is a very simple one-liner that can be used to start an HTTP server. And I wrote a little replacement for that. But first, I would like to tell you a few words about me. I'm a software engineer here for more than five years. And most of my time here, I spent working on multimedia, especially streaming, and yeah, watching Big Bang Bunny. That's a video available with Creative Commons, and it's often used as a placeholder video in many services. So I got quite familiar with that guy over my years here. And a large part of that time here, like I've spent developing membrane framework together with Mateusz, and somewhere along the lines, like I became something called lead architect. I don't know what that means, but that's what stands next to my name. And now getting to the actual tool, I would like to start by presenting you how is it useful, when was it needed, and how I get the idea to create it. So in one of the projects I've been working on, we had basically Phoenix application that was linked with Membrane that was receiving requests and was doing the processing of recordings from web conferences. So there was a lot of files coming from the different speakers inside the conference. It was all sent to that service with requests containing JSON, and among other data, there were a list of URLs on how to get those files. So the service basically was making a request for that files, download it, and then processed them. And one thing, the problems that we encountered are that we had bug reports that were tied to specific input files. So we were getting that reports, we were getting the files, but we had no access to the actual server that they were placed on. So there was a problem of how to reproduce that issue. Of course, we could change the implementation and allow the service to read from a file instead of URL. But as most of the programmers were lazy and we didn't want to do that, so the most simple solution for that is to get all those files. We were getting them zipped, so unzip them, replace that JSON that was also provided, replace the URLs there with localhost, and run the simple HTTP server so that our service then can make requests there and download them. Yeah, that was the first time I've noticed we're having only Elixir application, and out of nowhere the wild Python appears. That was the first time I thought I could do something about it. Here's another use case for such server that I call ad hoc HTTP server. And it's when working with the HLS, which stands for HTTP live streaming. That's a protocol done by Apple. Basically, not getting into the details, it's just a playlist, text file that contains among tags either a link to another playlist, or as you can see down here, the actual files. So the player that receives the playlist reads it and makes a bunch of requests for all the playlists and the files it needs to play the stream. And once again, this is where the such server is useful. This is an excerpt from one of the demos that we have in Membrane. That was actually presented on the last meetup here. So it was getting the feed from your camera and producing the HLS. But then in order to play it, one will have to serve it somehow. Since the demo was very basic, there was no HTTP server there. So the most straightforward solution is to just run a server in the folder where all the output is generated, and then pass a proper link to a player. And once again, we have an Elixir project, and all of a sudden we have dependency on the Python. We require someone to run Python. And yeah, we are all Elixir alchemists, programmers of Elixir. So and most of us don't have to know the Python and know such tool exists. And we have existing HTTP server. So why don't we use it? And I just wonder how hard could it be to replace the Python here with some Elixir equivalent. And as it turns out, it's pretty simple. This is the EXS script I created, proof of concept that it can be done. And as you can see, it's only 25 lines long. I'll walk you through it quickly. The first thing to make it happen was the mix install. It's quite recent addition to the Elixir. It was added in 1.12. Currently, we're running 1.13 with 1.14 releasing soon. So it's quite recent, and I guess that's one of the, like, let's say, byproducts of developing Livebook, and which is quite nice. Like, without this mix install, all of this probably wouldn't happen. As I said, I'm lazy, and I wouldn't want to start a whole new mix project in order to just check if it's possible to do this. So mix install is just getting the dependency. And yeah, as a side note, this mix install is also super useful with Benchy. This is also the find I've found on my computer. That probably I've created it doing some review when I was checking if one solution to generate bit string out of a list of atoms is better than the other. So yeah, with not many lines of code, I could just quickly check if my suggestion was correct, and it turns out it wasn't. So getting back to the script, after getting the plug with Cowboy, so the actual HTTP server, I needed to create a simple module that is plugs pipeline. All it does is, like, I've attached a logger, and the core of that pipeline is plug static, which serves the files. This whole thing is like almost copied straightly from the docs for the plug static. The only thing I had to change was the from option passed to the plug static. So I put simply file cwd, which stands for current working directory, and it meant that this plug will be serving files that are placed in the current working directory. And if it's not able to serve that, the execution continues to another plug. This definition says that this plug is actually a function, which is defined below, and simply this function returns 404 in case we were not able to find the file and serve it. Having that module, the only thing left is to start the Cowboy server. Like, I guess that's not the usual way people start it. Like, most of the times it's somewhere in the boilerplate generated by Phoenix. If someone was starting, then probably he was doing that via some supervisor, so using the spec with plug Cowboy. But it turns out, after a bit of search, it turns out that the plug Cowboy provides a way to start like the server in place, and then just something I needed to add to make the script not shut down the execution after that. So that this kind of a hack to make it persistent. And like as the presentation says, I could reduce the number of lines of code needed to create that by replacing that with process sleep. Great, and it worked. This was actually something that I used in the first example I provided. So the script was sitting there. And yeah, we're done. Thanks for your attention. We could go for the pizza, but yeah, I'm not only that I'm lazy, but that I have a bit of a perfectionist in me, and this is not quite the replacement for the Python tool. There are still some features missing that I often relied on. The most basic ones are the way to configure it, change the port number in case the one that I put there was already taken, and it's not nice to have to edit the file to switch this port. The same goes for the directory. Like it should be possible to serve the files from different directory than the current. And one more feature that I sometimes used was directory listing. So the script I shown in case the path requested was a directory would simply return 404 because there's no such file. But the Python tool in such scenario generates an HTML with a list of all the files in such directory. It's like interactive list, like you can click on the link, and it can be used to easily transfer files between computers in local networks. Like I used to send big files just from one computer to another in my at home. And one more thing, for that to be actually a valid tool, is a way to share it with other people. And yeah, is the EXS script good for that? Like at first, I thought that it might be problematic to get the arguments passed to the script, but it turns out that just calling system argv allows you to get whatever is passed to the Elixir script. So yeah, that's something I expected to be troublesome, but turns out to be solvable. But there are other problems. The first one is like with the reusing that for other people. The users would have to download that file and putting it in one place would mean that anywhere they go, they would have to like call Elixir and then the whole path to the file, unless they somehow work around it. It would be nice to provide something like that out of the box. That's the bare minimum you expect from a proper tool. Then, like, it's a minor caveat, but yeah, after you get that script, you just the first time you start it, it starts to download the dependencies, and then only then the compilation happens. So that's something also not expected from a tool. And the limitation of EXS script is that, well, it's one file. So in case of like growing of this tool, it would be quite a mess and not really maintainable. So it's kind of Mach for that thing. But it turns out there is something in Erlang ecosystem, and Elixir has some sugar to use it. It's called eScript. Yeah, this is excerpt from the docs for the task in Mix tool that describe it. So it generates a command line tool, like an executable. So yeah, that's what we want here. The downside is that it still requires Erlang to be available on the machine. But since this tool is addressed for the Elixir community, I guess I could live with that. And yeah, it takes all the dependencies, compiles them, and all the modules that are part of the project, and creates a whole package. So I can use more modules, place them in more than one file. So great, we can try to use that. And like here are the steps that are required to create an script from the script you've seen before. Unfortunately, this was the moment I had to start a new Mix project. But having done the POC, like I was already coped with doing that, and there I could move the module I defined inside the script. Then, like the eScript API requires to have a module that will be implementing the main function that will receive the argv, the arguments passed from the user. So its responsibility would be basically the same as the EXS script, like all the logic happens there. An entry inside mix AXS that will tell mix where to find that module. Okay, and this of course led to a bit of a problems. The first one was obviously finding a name. With EXS script, I could name it anything. Starting a mix new, I had to type some name. And since we're dealing with Cowboy, that is actually doing serving the files, the thing that came into my mind was Manger. Basically, the box you can see here that the cows eat from. So the cowboys serve the meals for the cows inside of Manger. So there, once I typed it, I never thought about it again. And probably if you have any suggestions for a name, I can hear them after the presentation. Then next thing that I had to do was to parse the arguments. I was actually surprised to find that there is an option parser in Elixir that was ready to use. But it's definitely not often used. It's I haven't seen many CLI tools written in Elixir. So it seems it lacks some features that I think maybe at some point I may suggest as a maybe I will make a PR to the Elixir itself. But something that is common in other languages and it's missing in the Somscript parser are default values for the options. Like there is no way to say that by default I want to use port 8000 or something. I just need to add it to the parsed result of the parsing. Another thing that usually in other languages the parser accepts like a big set of options. So the short name, the long name of the option, the type, and the default value if it's available, and the description. And out of that, the parsers usually generate the help for that, which is like automatically added. So if you type the name of the tool and then -- help, you will get the list of the available arguments, and that is totally missing in this tool. I also don't quite like the API here. I think you separately provide a list of the options. You would have to check the docs what the strict here means, and the aliases, like the short form for the arguments, are provided separately. So you have to like twice provide the name of the argument. But with all that being said, it worked well and allowed me to create a simple API, like arguments passing the port and the directory via either this short option or this longer form, in no matter the order or how they are. The short forms can be used together with longer forms. Okay. So now that I have all the arguments, I had to pass them somehow to the server. Like starting the new Mix project, I created the cowboy, started the cowboy just as I usually would in Phoenix. So I created an OTP application, and the problem is that the application starts right with the whole eScript. So at the moment the code from the main module was executed, the application was already there. So I had no way to pass the arguments. And to work around it, I needed to disable the application. I started manually from within the CLI script, this main function. And the application only gets the static args that are defined in mix.axs. So anything dynamic was not available. So yeah, this was the way to disable the application start. You just have to set the app to nil, and that's in general that's the definition of eScript. Here's the main module that I'm using. Yeah, and I decided to go with the way to configure an application is to put it in application env. I realized creating this slide that it could be achieved by moving the start of the server into supervisor, like not the application, but supervisor would allow me to pass the arguments there and change the spec of the run process. However, it would not solve another problem, would be that is passing the configuration to the plug static. Well, this whole plug pipeline is defined at compile time. So whatever was in the from was executed while at compilation time. So for script, that was okay because the script was compiled each time it was run. For such application, it is not. Thankfully, the guys creating this plug static thought about it, and there is a way to dynamically get a value for this from attribute, and by passing module function attributes tuple, this plug each time it looks for a directory, calls that function, which is defined in this module below, and this function is responsible for getting the directory configured from the arguments parts from the CLI. Okay, and one last addition to the script was the directory listing. That's probably the biggest module in the whole app besides mix.axs. This simple code, it's mainly a string with very basic HTML. It kind of reminded me of my childhood and creating my first website. And yeah, this is how it looks. Pretty basic stuff, but actually the Python does not look any better. So yeah, that's okay for me. And if you want to try it out, it's already there on the GitHub. With that first, let's say that this QR code will take you to the repo with the README, and this command will download, build, and create an script. And there is a bit of a downside that of using eScripts, that you still have to have the proper path added to the path environment variable. But I already have done that. At first, I haven't noticed that it might be a problem. And after that, just calling the Manger it's available just like any other binary and you can pass an options to it, and running it, and then visiting the local host in your browser will show the contents of the current directory. What's next? What can be done? What can be improved? My first thing when I saw especially the point number 2 was, that's not perfect either. So the way to go would be to create an actual binary out of this project. And for that, I think using Elixir Burrito seems like a good option. Basically, it uses Zig and Ziegler to create a wrapper around the whole application and generates binary that embeds the whole OTP and everything needed for the app. The API can be improved, of course. The help I mentioned would be super helpful. Yeah, with the description, like it's not provided by the option parser, but it can be done manually. One option that is available in Python and it isn't right now in Manger is the bind argument, which you can use to set a different IP for the server to bind to. And of course, the improvements can be done around this directory listing. The one thing I'm missing from the Python is the link to the parent directory. That's can be easily done. But it can be extended and further with metadata, so we can create listings like, for example, I think Apache does, so we can have a last modified date and the size of the file and so on and so on. With the styling maybe, and with the architecture we can add a template engine, and I would no longer have to write a string containing HTML, and probably there can be many more things done, so I'm open for ideas. Are there any questions? Okay, thanks for listening, and this is finally the time for the pizza, beer, pool, and all the activities that you can enjoy at our office. Thank you. Thank you.
Okay, thank you very much, Bartek. And as Bartek has just said, it's time for pizza, beer, and pool. Okay, so first let's finish the official part. So I would like to say goodbye to all those who are watching us. So goodbye. And now let's get this party started, as Bartek has suggested saying.